things. Okay, gonna kind of go backwards a little bit here with the fraction stuff to make sure we've got this. So, first example, no variables involved, just regular plain old two fractions. We're trying to find a common denominator. Now, when I'm dealing, and this would be like a coefficient, because you'll notice down in 2 we'll start getting into variables, but it's going to work the same way. You're always looking for that smallest number that both of these would divide into if we were looking at it as factors. I thought about doing a factor tree, thought that would make things worse. So if I'm looking at 4 and 10, what would my common denominator be? Okay, my common denominator here would be 20. Now let's see how I can hopefully not get this too messed up here. And again, if you're not sure on that, basically what you're doing is saying, okay, if I started counting by 4s and counting by 10s, what would be the first number that both lists would have in common? Okay. I don't want to just multiply them together. Would that get me to the right answer? Yes, it would. But I'd have another spot in there that I'd have to reduce more, and I really don't want to have to do that. So when we're going to build fractions, it's the same way here as it was yesterday. Whatever you have is already there, but now the question I'm asking myself is, okay, what do I multiply 4 by, maybe, there it is, to get to 20? Well, 4 times 5 is 20. So that's the part that gets added in up above. What do I multiply 10 by to get to 20? Okay, I multiply it by 2. And then I can have my two denominators that are now the same, but I've built my coefficient, and I can get to the answer. Okay, so that's going back a ways. I mean, that's probably like later grade school, early middle school, something like that. But that's just the first part of what we're doing. Once I get that part situated, then we're ready to move to our next step, which is to start adding variable terms. So again, start with the coefficient. If I'm looking at 3 and 5, what's my LCD going to be with those two, just the numbers? 15, okay. So I know 15 is going to be part. Now we're ready. Okay. When you have single variables, variables without that plus or minus bond, okay, we just want to take the largest exponent. So my LCD here is going to end up being 15x squared. Okay? Because if I don't take the largest one, when I go to try and build, it's like, ooh, I just have x and there's an x squared here. That doesn't quite work. Because remember, the whole idea, whenever I'm trying to build these fractions, and it's the same when it was just the numbers, I need my denominators to be the same, and my job is to see what can I multiply my old denominator by to get to the new one. Well, I've already got the x squared part. What do I have to multiply 3 by to get to 15? Okay, I need the 5 still. Because I want equivalent fractions, I just need the denominators to be the same so I can work with them. Over here, okay, 5 to get to 15, I need 3. X to get to x squared, I need another x. Because that's our whole game here. To get from here to here, what do I need? Whatever I need is going to go up here. And once I have that, I can get into this business. Oops, let me move that up a little. However, if I can simplify things, even if you think you're not going to be able to cancel anything, I still should simplify. For instance, here, I can take a 2 out of each of those. It's always better to be safe than sorry. But once I do that, again, I can't touch my binomial because that plus is bonding them. If there'd have been anything between this 2 and this 15x squared that I could have canceled, I would have. But there isn't, so I can't. Okay. Before we go bombing along into binomial terms and things like that, are we okay so far? Because if there's an issue so far, we need to get that taken care of before we go doing any other stuff. I'll get to it. I know you do, but we're okay so far. Okay. So then we're going to add into our third part. Whenever there are quantities, okay, and that just means sets of parentheses, each different one gets included. Okay, now this is after we've factored everything. I'm only going to use squared if one of the terms has two of the same, sort of like we ran into yesterday where we had that x plus 2 squared. So here, I can't factor this. Can I factor this at all? Yeah. I can take a 2 out of there, and I'm just left with x minus 4. And if I ever factor my denominator, I'm going to cross the old one out. I don't want to think about that. So then I work my way down my checklist. So let me slide this down a bit. And I start to look, and I say, okay, do I have any coefficients? Yes, I have a 2. Okay, that's part of my common denominator. Do I have any single variables that are just hanging out on their own? No, don't have to worry about that part. Do I have any quantities? Yes, I have sets of parentheses. Okay, every one of those that's different needs to be included as part of my LCD. So that is my LCD for this one. But I've got to go through those 3 things to get there. But once I have, now I can go about building my fractions. And now, just like what we started up yesterday with, I'm going to jump in here and say, okay, I've got the x plus 3, but I don't have the 2, and I don't have the x minus 4. So I got to get both of those in here. In my second fraction, I've got the 2, I've got the x minus 4, but I need the x plus 3. And once I get that, again, now I can start working on getting this down to one fraction, and then I'll be able to see if there's anything I can reduce. So here I got to do a little thinking ahead of time. Here, 4 times 2 is 8, so this is really 8 times x minus 4, because I just multiply the coefficients together, then I'm going to distribute. So I've got 8x. 8 times negative 4 is negative 32. And then distribute over here. So 2x plus 6. And now it's just a game of combining like terms and taking that one last look to say, okay, got one fraction, combined my like terms, did all my other work. Anything I can take out of the numerator? Or is that just done? Is there anything I can take out of here? Take out a 2. You're like, well, gal, it's just 2. What good is that going to do? Oh, it can make a difference. Because in this case, once I take out that 2, these guys are both just hanging out on their own. If I'd have stopped, I wouldn't have been quite simplified, because that's now my simplified form. Because those 2's, I can't see the bond. Multiplication bond's weak. I can whack those parts. So now there's one last challenge. One last one. I look at number 4, and I go, okay, these look like they're factorable. What's my first denominator going to turn into? What multiplies to negative 10 and adds to negative 3? All right. Again, once you factor it, wipe out the old one so we don't get confused. What about my second one? X minus 5 and x minus 5, or x minus 5 squared. Here's where we find out what we got. What's my LCD going to be? Okay? Because again, if we're looking at our quantities, each different one, so we know we've got x plus 2 and x minus 5, but if I have a squared in one of them, okay, it's sort of like the variable rule. You take the largest exponent you see on a term. X minus 5 squared. Squared's the larger exponent. Squared goes in my denominator. That's going to be the biggest challenge of this whole section, is just remembering, okay, if I see things with exponents, I've got to take the biggest one. Because once I've done that, now I can go back and say, okay, I've got the x plus 2, and I have one of the x minus 5's, but I need a second one. In the second fraction, I already have the x minus 5 squared. I need the x plus 2. Okay. Is the building seem a little bit better now with this? Oh, I'm going to get silence. Because I'm not worried as much about the rest. I know you can distribute and combine like terms and things like that. Okay. Yes, now I will take on your question. Let me pause this for a second. So as we head to the back of the notes to finish the regular notes, here's my one suggestion when you get into complex fractions. Break them up into separate problems, and here's what I mean. On this number 9, I'm going to pretend that denominator is not there at the start. Because by doing that, I can say, okay, I just want to deal with these. Now the 3 is not a fraction. So I'm going to put that over 1. Because I like dealing with fractions. So up here, they're like, hang on, Hardy, we got to get this out. Once you get it out, and we forget the fact that there's a denominator there, what's my common denominator going to be just up here with what I see? Yes, but you can see on your sheet.
What are we doing again?
We're on the note sheet. Some of you that are off doing homework need to come back to this. I will give it to you as soon as we are done. My coefficients right now, I see a 1 and I see an x. What's my LCD?
1.
Part of it. Okay, 1x, or just x. So if that's going to be my LCD, I already have the 3 and the 2 that are in the numerator. to get from 1 to x, what do I need? An x. In the second fraction, I already have x, so I don't need anything else. So what I'm going to do here is I have 3x plus 2 over x, okay? That's my numerator simplified. Once I simplify just that part, I'm going to flip this over, and I'm going to do the same thing, just dealing with the denominator. So again, I'm going to look and I'm going to say, okay, my LCD down here also is just x, or 1x. So again, I'm going to build my fractions based on that. Put in what I have at the start, and then say, okay, going from 1 to x, I need an x. Going from x to x, I don't need anything. I could put 1 there if I wanted to. Okay? So here, I end up with 4x minus 3 over x. So you're like, all right, so we've done each one separate. We've simplified them as much as we can. Now, I'm ready to deal with this. So remember, we're going to take the reciprocal of the bottom fraction, because that's actually what I'm dividing by right now. Okay? If looking at it this complex way bothers you, you're like, I just can't see what you're thinking about here, here's what I'd suggest. Let me rewrite it, at least for this first one, using, right, horizontally, just using the division sign. And let's see if this makes it a little bit easier to work with. So I can take it out of complex, put it into its horizontal state, and then take my second fraction and flip it, just like in the last section when we were doing this. So I leave the first one alone, but I'm going to flip or take the reciprocal of the second one. So once I do that, can I cancel anything? Okay, the single x's can cancel. And then I just multiply across. And I'm ready to go. So on any of these, and yes, we're going to do the super deluxe one at the bottom in a minute, but I want to do number 10 here first. Oh yeah, we're going to do super deluxe. So when I get over to 10, again, forget that that denominator part's even there for the moment. If you have something that's not a fraction, we're just going to put it over 1. So what's my LCD going to be? Okay, my LCD is going to be 2. So again, build your fraction. The x plus 1 that's already there will stay. The 4 that's already here will stay. And again, you're comparing your old fraction to your new one. Well, you're like, well, it's already a 2. Can I just leave it? Yup. But when I move to the 4, I used to have 1. Now it's 2. 1 times 2 is 2. So, I'm like, okay, let's see here. This is going to be 2. So I've got x plus 1 plus 8, which would be x plus 9 when I combine like terms, because I'm just adding. I'm not going to multiply that. So that's simplified. That part's ready to go. So I'm like, okay, what's going on down here? Oh, it's just 6 over x. I don't have to do anything else to this. Okay. So there's my complex fraction. But again, if that drives you crazy, if you would like, just keep looking at it as though it's horizontal. You're just dividing by the fraction on the bottom in the denominator. And then just say, okay, now I'm going to take the reciprocal. I'm going to flip this. Does anything look cancelable at this point?
No.
No. So at this point, I'm just going to go ahead, multiply across. I take one last look. Those are next to each other. That's factored. I don't want to multiply it out. Okay, that's as far as I can go. So basically, we're doing the numerator and denominator separately in these, like they're their own problem, and then we flip the bottom one when we get done and work it. But now let's look at the big kahuna down here. Because we're not letting that freak us out. Shoot. All right. First things first. Denominator, you do not exist. So, the denominator is factorable. It's a sum of cubes. So what do I cube to get each of those terms?
4.
Okay, so 4 and x. Let me move this over in jumbo size here a little bit so we don't get, if it gets back into focus, there we go. So when I go to factor this, I have x plus 4, because again, it's just the sum of those two, because the plus tells me that. And then I square my first term, so x squared, change the sign, multiply my two terms together, and then square my last term. So the only thing I'm going to do for my numerator fraction is factor the denominator. And that's as far as I can go. There's nothing else to do. When I switch it up and look down here, now it looks like there's a little more work to do. X squared minus 16 in its factored form, what's that going to look like? Okay, x minus 4, and x plus 4. Okay, so we'll wipe that out. What about my second fraction? Okay, 3, the biggest thing goes into 3 and 12, and I can also get an x out of there. End up with an x plus 4. And again, once I get that out, we'll scratch that. So let's see here. And we won't be looking at 11, so we can kind of take some of that room up here. What's my common denominator going to be? 3x, 3x, because I have one coefficient and I have one single variable. And then I look for each different set of parentheses, each unique quantity. So my LCD is going to be 3x, x plus 4, x minus 4. So that is what I'm going to use to build my new fractions. And just like we started to do yesterday, basically I'm just looking at this now saying, okay, going from my old denominator to my new one, what do I have already? I got the x minus 4. I've got the x plus 4, but I don't have the 3x. So I'll put that in there. When I move to the second fraction, I've got the 3x, I've got the x plus 4, I don't have the x minus 4. So when I finally make it to this last part of this one, I go, all right, let's see what we got here. We got 15x, and this is like distributing through a negative 2. So 15x minus 2x would be 13x. Negative 2 times negative 4 is positive 8. Nothing else is going to cancel. Do not try to whack those x's. Okay? These are bonded. If we want to put the parentheses to remind us, we can. But that's as far as this one goes. So you're like, okay, so now what the freak? So out of all of this, here's what our final dealing looks like. There's my original numerator. And since this is my denominator, I know I'm going to have to flip it anyway. Move this up a little bit. I know I'm going to have to flip this one anyway, so I'm going to go ahead and I'm going to do that. Now sometimes, even after all this work, there's not going to be a ton of things that I can deal with here. Because I start looking, I'm like, is there anything I can cancel?
X plus 4.
Just the x plus 4. Those guys wipe out. And then let's see what big mess we've got left here. So 3x, x minus 4, over all this stuff down at the bottom. And if you get to this point and you're looking, you're like, that doesn't cancel. Well, maybe I could factor this. No, I can't factor that. No. That's about as far as I can go. And that's all you're going to be able to do on that particular one. So that's kind of between what you've got with the regular homework assignment and then that sheet you picked up today, what we're doing. Monday, as you will see up on the front board, basically is going to be dealing with the worksheet that you picked up today. So I'm assuming now we can knock out some of the rest of the bookwork or start some of it if we haven't. Tuesday will be the quiz preview, and then Wednesday will be the homework check and the quiz on this stuff.